Number 24 is a tough problem right here, although we are still in the nice category of the homework right here, where they tell you what to let u equal to start your substitution. But let me pretend for just a second that that's not there. We've got this complicated integral of a quotient right here. Inverse tangent of x, quantity squared up on top, and an x squared plus 1 on bottom. Now I want to talk about this because it's not uncommon that we're trying to integrate a quotient with variables on both the top and the bottom. And I do need to say that in the majority of these types of problems, we're going to let u come from the denominator of your fraction. But do me a favor, don't write this down. If I were to let u equal x squared plus 1, I certainly could do, we run into a problem almost right away. Du then would equal a 2x dx. In no way, shape, or form can I turn that into this. Inverse tangent of x quantity squared. So that's a dead end that happens pretty quickly. This is one of the rare exceptions here, guys, and there's really two categories of them where u is actually going to come from the numerator. Now remember, what you're trying to do here in general terms is look at your numerator and your denominator and think, okay, is the derivative of one of those two parts going to give me the other part, or can I manipulate it in order to do that? And inverse trig is one of those two exceptions I just spoke of, where often, I won't say always, but often you're going to let u come from the numerator. And let's see why that is real quick. I guess I'll just go ahead and show you rather than talking in circles. I'm going to let u equal not the 2, everybody, but just the numerator's base, which is going to be the inverse tangent of x. And then, when we go to differentiate that, this is what makes inverse trig interesting. The derivative of an inverse trig function is going to put a variable in the denominator now. The derivative of inverse tangent is going to be 1 over an x squared plus 1 with a dx at the end of all that. So if you guys notice this right here, my primary substitution will come from the numerator, but my secondary substitution needed to cover this, which is dx divided by x squared plus 1. Well, sure enough, that's exactly what we have right here. So actually, this substitution isn't that hard, guys. This integral now is, okay, here we go. The numerator becomes u squared. So I'll just go ahead and put that here. And then the denominator, well, there really is no denominator. Dx divided by x squared plus 1 just gets replaced by a dx. That's it. So this is one where they just kind of put training wheels on the bike here, guys, and said, okay, this is how you do a problem like this. I would imagine that later on in this homework section, there's going to be at least one problem similar to that where you've got to figure that out on your own. But once you get the substitution here, this is actually a pretty easy integral, guys. Antiderivative of u squared is going to be a 1/3 u cubed with a plus c at the end. And then we'll go ahead and replace the u with what it was initially, the inverse tangent of x. So we'll write that as a 1/3, an inverse tangent of x in the parentheses. We will cube all that, put a plus c at it, and that is all she wrote, everybody. So that's our answer for problem number 24.